Hi, this is a tutorial to know how to write IUPAC names for hydrocarbons and also to know how to draw structural formulas from IUPAC names. First of all, the IUPAC is the International Union of Pure and Applied Chemistry. It is an international organization not affiliated with any other government. The IUPAC serves to advance the worldwide aspects of the chemical sciences and to contribute to the application of chemistry in the service of humankind. Now, in organic chemistry, a hydrocarbon is an organic compound consisting entirely of hydrogen and carbon. There are four types of hydrocarbons: alkanes, alkenes, alkynes, and aromatics. And it's important to have rules to name hydrocarbons because with that we can give an special and different names based on its characteristics and bonds. And there are four common hydrocarbons: methane, ethane, butane, and propane.
My name is Marisol and I'm going to talk about the alkanes group. The alkanes group is a type of hydrocarbons that have only single bond, and the rules in name it this type of hydrocarbon. So is the IUPAC rules, and well, the way in which we name it is the following. First, we need to circle the parent chain, which is the longest chain of hydrocarbons. The second thing is number each carbon from the end to the near, in which we have a bond. 1, 2, 3, and 4. And we need to add the prefix A and E. In this case, we have 4 carbons, and the name is butane. We do another example. So the chain. And number each carbon. If we have 5 or more carbons, we add the Greek prefix penta, hexa, hept, octane, nonane, etc. In this case, we have 5 carbons, and the name is pentane. We add the Greek prefix and the prefix of the name A and E. So thank you, and it's all.
Hi, I am Laura and I am going to talk about alkene. An alkyl group is a functional group like an alkane that consists of a single bond of carbon and nitrogen atoms. Alkyl group is divided in methyl group, ethyl group, propyl group, and butyl group.
My name is Marisol, and in this case we want to talk about the alkenes group. The alkenes group is a type of hydrocarbons that have a double bond in each chain. Well, the way in which we need to name this type of hydrocarbons is different because the rules change for this. Well, the first thing what we do is circle the parent chain, which is the longest chain. The second step is number the chain from the end to the near, in which we have the double bond. So for name this, we keep the location in which we have the double bond. In this case, we have the double bond in the second carbon. And we have 5 carbons, is to pentane, and add the prefix E and I because the name. We do another example. Is this? We have 5 carbons, and the number and the location of this double bond is the one, the first carbon of. So the name is 1-pentene, because we have 5, and the prefix and the location. So this is all, and thank you.
Hi, my name is Keren, and in this tutorial I will talk about alkynes. First, let us start with the definition. They are hydrocarbons, and by hydrocarbons I mean that they are compounds formed by carbon and hydrogen atoms. And between the carbon atoms they have at least one triple bond. Its general formula is CnH subscript N minus 2. Which means that it will always have a certain number of carbon atoms, and that number will be multiplied by the subscript 2 of the hydrogen atoms, and from that multiplication we're going to subtract 2. And that will be the number of the hydrogen atoms in the formula. But this is only the molecular formula for the alkynes. Now, here we have 4 examples of alkynes, and we're going to show where the names come from. To start, the names eth, prop, but, and pent come from the alkanes. And the alkane with 2 carbon atoms, it's called ethane. But in this case, we have 1 triple bond. So it's going to be ethine with Y. Now, the propane has 3 carbon atoms. Here we see them. But because we have the triple bond, it's going to be propyne. The butane has also a triple bond, and it has 4 carbon atoms. But in this case, the triple bond is not located in the first or in the last carbon atoms. So we're going to add a number. And this number is added first by counting 1, 2, 3, and 4. It doesn't matter where we start because the triple bond is still in the middle. So, because the triple bond is in the second carbon atom, we're gonna put 2 butane. And in the last one, it's a little bit different because we have 2 triple bonds and 5 carbon atoms. So it's gonna be pent, and because of the 2 triple bonds, it's gonna be ion. We're going to count now where are located the triple bonds. Here we have the first one, the second one, the third one, fourth one, and the 5th carbon atom. That's why it's called pent. And the triple bonds are in 1 and in the 4th. Now let's make one by ourselves. We have here this structure. We have 1, 2, 3, 4, 5, and 6 carbon atoms in our principal chain. And in the 4th one, we have this that is called methyl. We're going to write it over here. This one is methyl. Now, we're going to number according to where the triple bond is near. So it's going to be 1, 2, 3, 4, 5, and 6. After that, we are going to name this. First of all, the methyl is in the 4th carbon, so we're going to write 4 methyl. Then, where is this in the second one? 2, and the complete name. We have 6 carbon atoms, so it's going to be called hexene. And that's all. Now, we're going to make another exercise, but now we're given the name and we have to find the formula. In this case, because it's a butane, we know that between 2 carbon atoms there will be a triple bond. And it says the number 2. So, we know that the triple bond is in the 2nd carbon atom, so we're missing 1 here. And it says that it's a butane, so there must be 4 carbon atoms, and the other one we're gonna write it over here. Now the next thing we have to do is find the hydrogens missing. In this one we have 1 bond only, so we need 1, 2, 3 hydrogens. We're gonna write it over here. After that, this one has 4 already. 1, 2, 3, and 4. This one too. 1, 2, 3, and 4. And this one is missing 3 hydrogens. And this is our formula.
Hello, my name is Paola Montoya, and I'm gonna talk about aromatics, which are benzene and toluene. First of all, we have to know that all aromatic compounds are based on benzene, which has a ring of 6 carbon atoms. First of all, we have to know that this is the basic structure of a benzene. So, now, we are going to learn the steps to name aromatics based on the UPAC. So naming an organic compound requires several steps. First, find the longest continuous chain of carbon atoms. This longest chain may not be written in a straight line. Name the longest chain. Find the substituents that name each of them with the appropriate group name. Number the carbons in the chain such that the lowest number is given to the group nearest one end of the chain. List the groups of alphabetically in front of the longest chain name. Precede each group name with a prefix indicating how many of them are present in the molecule. In front of the prefix, list the numbers of each group in the molecule and separate the numbers with a hyphen. Here we have the structure of an aromatic benzene that we want to name. The first thing we have to do is to enumerate every corner, no matter what the order is. Now, we will write all the numbers where chloro is located, separated with a comma. So it will remain like 1, 3. Then we have to write the name of our atom, separated by a hyphen. In this case, it is the chloro. But as we have 2 atoms of chloro located in different places, we will use the prefix D. So it will remain like 1, 3 hyphen dichlorobenzene. We also can use the prefixes ortho, meta, and para, instead of putting the numbers in our formula. So using them, our formula will remain like this: meta hyphen dichloro. Let's apply this with some examples. So, if we have this, what we first have to do is to enumerate our corners, 1 and 2, no matter the order. And then we're gonna circle the numbers where our methyl is located. In this case, it will be 1 and 2. Now, first of all, we're gonna write the numbers separated by a comma, 1, 2, and hyphen. And as both of them are methyl, we're gonna use the prefix D, and then we're gonna write methyl benzene. Now, if we have this, we have here methyl, and we have here ethyl. We're gonna first enumerate the corners, 1, 2, 3, 4, 5, and 6. Then we're gonna circle where methyl is and where ethyl is. And then we're gonna order them alphabetical. Methyl, well, it starts with M, and ethyl starts with E. So this one will be the first one that we are gonna put in our formula. So we will write the number 5, and then hyphen ethyl hyphen. Now we're gonna go with methyl. 1 hyphen methyl benzene. And now we have this. And here is chloro. Here is methyl. And here we have ethyl. First, we're going to enumerate. Now let's start from here. 1, 2, 3, 4, 5, and 6. And we're going to circle 1, 4, and 6. So alphabetically, it starts with C, this one with E, and this one with M. So we're gonna first start with this one. So we're gonna first write number 1 hyphen plural hyphen. The next one could be ethyl, so it will be number 4. Ethyl, now hyphen, and finally it will be number 6 hyphen methyl benzene. Now we're going to learn the steps to draw structural formulas in aromatics. So first of all, if you know it is an aromatic, you have to start drawing its basic structure, which is an hexagon, like this one. Then you have to locate the numbers that have been given to you in the formula inside the benzene. For example, In this case, the formula is 1,3 bromo 2 chlorobenzene. The next step is to write bromo and chloro in their respective place. The structural formula for this benzene would be 1,3 bromo 2 chlorobenzene. Now toluene. For toluene, it is going to be almost the same, but we are going to circle our main chain starting with methyl number 1, like this. Now, we will name it counting from the second number, instead of the first one as we did with benzene. It would remain 2,3,5 hyphen 3-methyl toluene. Now let's apply it with some examples. So here we have 1 bromo 2 chloro 3 methyl benzene. So first of all, we have to draw our figure. Once our hexagon is already done, we have to enumerate each corner, no matter the order. And now we are gonna write bromo, chloro, and methyl corresponding to its number. So first, bromo is number 1. So here in bromo, we are gonna write BR. In number 2, it is chloro. So here we're gonna put Cl. And in number 3, it is methyl. So here we're going to write methyl. And this is the way our benzene remains. So now we have this 2 bromo 3 chloro 5 methyl benzene. We are gonna draw the hexagon first. And then we are going to enumerate the corners. 4, 5, and 6. And here now we have to place first bromo. So bromo, the formula says is in number 2. So in number 2, we are gonna write BR. Chloro is located in number 3. So here it's Cl. And in number 5, it is going to be neutral. And this is the way our structural formula will be. Now in this example we have 4, 5, 6 3-methyl benzene. So what we are going to do first is to draw our hexagon again. And we are going to enumerate and then we are going to locate the methyl. So it says it is in number 4, in number 5, and number 6. So this is the way our structural formula is made.
Hello, my name is Daniela Salivar, and today I'm gonna tell you what it's a cycloalkane, and I'm gonna explain you what it is and give you some examples. A cycloalkane are types of hydrocarbons compounds that have one or more ring of carbon atoms in their chemical structure and in their molecule. Alkanes are type of organic hydrocarbons compounds that have only single chemical bonds on their chemical structure. Cycloalkanes consist of only carbon and hydrogen. And some examples, it's cyclopropane. Cyclopropane is this. It's in the shape of a triangle and it consists of one carbon here, and one carbon here, and two hydrogens here, two here, and two here. Its formula is C3H6, so that means it has 3 carbons and 6 hydrogens. Another example is cyclobutane. Cyclobutane, it's on a shape of a square and it has one carbon here, one carbon here, one carbon here, and one carbon here. And it also has 2 hydrogens here, 2 hydrogens here, 2 here, and 2 here. Its formula is C4H8, so that means it has 4 carbons and 8 hydrogens. Another example is cyclopentane. Cyclopentane is this. It has 5 sides, so that means it has 5 carbons and 10 hydrogens. 1 carbon here, 1 here, 1 here, and 2 hydrogens here, 2 here, 2 here, 2 here, and 2 here. Cycloalkanes are classified into small, common, medium, large, and cyclopropane and cyclobutane are considered as small, and cyclopentane are